Hello students, here I am going to explain the static implementation of queue data structure, means implementation of queue with the help of array. We can also implement this queue data structure with the help of linked list also or dynamic array also, but that is a dynamic implementation. Here I am considering static implementation of this queue data structure with the help of array. Okay, see, you know this queue data structure, it is just like a real life queue. Okay, and there are two ends. The end through which we are inserting element inside queue, that is nothing but a rear end, like this one is a rear end and this is insert operation, it is called as a end queue. Okay, and the end through which we are removing element from this queue, that is called as a front end, and remove operation is called as a dequeue. Okay, and whatever element inserted first, that will be removed first. That's why it is called as a first in first out data structure. See, you have to just take care about these points, means you have to insert the element through rear only, you have to remove the element through front only, and whatever element inserted first, that will be removed first. This points you have to keep in mind while implementing this queue data structure, whether you are using static implementation with the help of array or dynamic implementation with the help of linked list. For both you have to consider these points. Okay, now here what we will do, we will first declare one array of a fixed size. Okay, let we have defined one variable like hash define max, and here you can set any size. Here I am considering 10 size, you can consider 5, 10, 15, anything. Okay, now here see, we will declare one array of this max size for implementation of this queue. How? Integer, let array name is queue and here size is max. Getting? This is a global declaration. The outside main I am declaring this. Okay, and here with the help of C programming language I am just doing this task, just implementing this one. Okay, now next thing is, see, here we have to declare ends, two ends. For that we will declare two variables, front and rear, like this, front and then rear. Okay, and both should be -1 initially. Why? Because see, whenever there is nothing inside array, consider this one is a array. Okay, and it is of size 10, 1, 2, 3, 4 up to 10 size. Now see, we will just do one thing, that front and rear, two variables we will declare front and rear, and see, this front variable will always hold the index of front element and rear variable will always hold the index of the rear element. Now currently there is nothing inside queue, means queue is empty, means here we cannot take initial value as a 0. Why? Because see, this array index will start with 0 and ends with 9. Getting? Always keep in mind, we have to just initialize it with -1, means front and rear both should be -1 initially. Getting? Means those will point here, means nothing is there, and whenever you will insert any element, then you have to increment that front or rear and so on. You have to do like that. Front and rear both we have to initialize to -1. Okay, front equal to -1 and rear equals to also -1. This is the variable declaration which is needed in this static implementation. Now we have created this array and we have just declared two variables like front and rear, and both are initially -1. Now we have to do the enqueue operation first. Enqueue means inserting element inside queue. Now what we have to do here, see, first we will declare the function like this. Enqueue means we are just inserting element inside queue, means there is no any return statement, means nothing we are returning from that function. That's why return type will be void. Now the name is enqueue, and here see, we have to just pass one integer value because we will call that enqueue function like this, enqueue, and here we are passing 5. Now 5 will get inserted inside that queue whenever we will call like this, and for that we have to write implementation. We will pass one integer value, let n. Okay, now n I want to insert in this queue. This is the meaning. Now how to do that? See, initially front and rear both are -1. Okay, if front and rear both are -1, then we can say that there is nothing inside this queue. Getting? See, we are just inserting element through rear position always, and suppose this rear is pointing to 9 and front may point to any index. Okay, but suppose rear is pointing to 9, means what? We cannot insert any more element here. Q is full now. That thing we have to consider first. That condition we have to place first while doing this NQ operation. Getting? Means here what we will check, if rear is equal to max minus 1. See, this 9 means max minus 1. Max is 10. Okay, max minus 1 means here we can say that Q is full, means Q overflow, and here we cannot insert any more element in that Q. Getting? that first we have to check. That's why here we will write like this, printf Q full or Q overflow. Getting? Now the next condition. See, suppose there is nothing inside Q and we are just inserting the first element in this Q, then what we will check, if front and rear both are minus 1, means there is nothing inside Q, means here the first element, 0th index, will be front as well as rear in that case. Okay, and suppose initially there is something inside Q, then we will not change front, only we will insert elements through the rear, means rear will gets modified in that case. Getting? Else, if front equal to minus 1, front is minus 1, means what? We have to just do front plus plus as well as rear plus plus. Okay, front equal to minus 1 and rear also equal to minus 1. In that case what we will do, we will just increment front as well as rear, and at that place we will insert the element front plus plus, rear plus plus, and we will just insert the element at that place in this Q array. That's why we will write like this, Q of rear you can write or front you can write, both are same, Q of rear, because now both are pointing to 0th index. Q of rear is equal to the element whatever passed. Getting? Now next, else suppose there are some elements in this Q. Suppose there is a element like this, this is the Q suppose. Okay, currently here are 2, here 4, anything. In that case this front is 0, okay, and rear is 1. Suppose there are 2 elements. See, suppose there is only one element, in that case front equal to 0 as well as rear is equal to 0. In that case also we have to insert element here at this place, means we will just increment the rear. If front is 0, rear is 1, if there are 2 elements, in that case again we have to do the same thing, rear plus plus, means here rear will become 2 and here we have to insert the element. Suppose we are inserting one more element, again we have to repeat that thing, means in that case only we have to just increment the rear and we will add the element. See, these two statements are same for this case. Again, if front and rear both are minus 1, that also, for that also these two statements are same. That will just increment the rear and insert element at that place, like rear plus plus and just Q of rear equal to N. Getting? This is NQ operation, means we have to just insert element inside Q with the help of this function. Now what we have done, see here this return type of function is void because this function is not returning anything, we are just inserting something inside a Q. Now the argument will be N. See, we have to check whether Q is full. Whenever rear equal to max minus 1, in that case we can say that Q is full, means Q overflow. That condition we have checked first, means we cannot insert any more element in that case. Now the next one, see, if both are pointing to minus 1, means Q is empty, means here in that case we will just increment the front, again rear also, and we will add element at that 0th index. That we have done here, like if front equal to minus 1 and rear also equal to minus 1, here only front equal to minus 1 we can write. Okay, then front plus plus, rear plus plus, and Q of rear equal to N, means at rear place, means at 0th index we have inserted the element. Otherwise we have to just increment the rear and we have to put the element at that rear place. That is same for all other situations. Getting? This is NQ operation. Now we have to see the DQ operation. DQ means removing element from that Q, and we have to just remove the element from front. Now how we will do that? See, first what we have to check whether that Q is empty. Okay, if it is empty, or you can call it as a underflow situation is there, then you cannot remove any element because there is nothing inside Q in that case. Getting means what we have to check, if front and rear both are -1, then we can display there Q is empty. We cannot remove any element from that Q. Suppose there are some elements in this Q like 2, 3, 8, anything. Now in that case, front equal to 0 and rear is equal to, now 0, 1, 2, this is 0, 1, 2 index. Okay, front is 0 and rear is equal to 2 now. Now in this case, suppose we are removing this element 2, then what we will do? See, we will remove this element means front will become 1. Again we will remove this element means front will become 2. Getting? And suppose we have removed this element, in that case front will be 3 and rear will be 2. Getting my point? See, suppose we are removing this element, then we will just increment the front, means front will become 1 and rear will become 2 in that case. Again suppose we are removing this element, then front will become 2 and rear also will become 2. Getting? Now suppose we are removing this element, now in that case front will be 3 and rear will be 2 as it is, means there is nothing in that Q. Getting? Now how we can do this? See, suppose front and rear both are same means what? There is only one element in that Q. In that case we will just remove that element and we will just assign -1 to front as well as rear in that case. Getting? Always keep in mind. And otherwise what we will do, we will first just display the deleted element which is at the front and then we will increment the front. That process we have to do only. Now considering all these points, I am just writing the DQ function. How to write? See, we are not returning that removed element, we will just display the removed element directly inside function. That's why no return type, means void then DQ. And here we are not passing anything to this function, means we are just removing the element from that Q. That's why there is no need to pass anything to this function. Now how we will do this? See, first we will check whether Q is empty. Q is empty means front and rear both will be -1. Okay, how? If front equal to -1, only this is sufficient, there is no need to check for rear also. Okay, in that case we have to print like printf Q is empty. Okay, now else there may be only one element, that is one situation. In that case what we have to do? Simple, else if front and rear both are same, equal to rear, means we can say that here both are same, means there is only one element in that Q. That element we will remove and we will just assign -1 value to both front and rear. Okay, how? Simple, front equal to rear means there is only one element that we will display like removed element, printf deleted or DQ'd element you can say, %d, comma whatever element present at rear, that is Q of rear. Okay, now here we have to just assign -1 value to both front as well as rear, like front equal to rear equal to -1. Getting? This is the second situation. Now the third situation is just a normal situation. In that case we have to just increment the front and whatever removed element we have to display. How to do that? See, like else just display printf again deleted %d, comma the element which is present at front, means that element we have to remove. Okay, here also you can write front, because here in this case front and rear both are same, that's why I have written rear, but it is better to write front. Okay, like deleted %d, comma Q of front. That's it, and just only increment the front. Okay, front plus. Getting? This is just a DQ operation, DQ function. Here what we have done, I am again repeating. See, DQ, this function is returning nothing and there is no need to pass anything to this function. See, front equal to -1, this means here q is empty, that condition we have first handled. Next, if front and rear both are same, in that case we have just displayed the element like deleted q of front and rear both are -1 now. Okay, because here whatever element present at front, that is the only one element and that we have to just display, means now q is empty, that's why we have to just set -1 value to front and rear both. Okay, otherwise that is a normal situation, we have to just increment the front only. Okay, whatever element present at front initially, that we have to just display as a deleted element from that queue. Okay, actually we are not actually deleting the element, we are just changing the front. Okay, means whatever element present at that front location previously, that is now a garbage value only. Okay, getting this is just a DQ operation. Now we have to just write display operation. In main we can call all these operations or all these functions by writing a menu driven program, or we can just call like NQ, DQ in that way. Okay, now see, in main we have to write like this, void main. Here first we will call NQ, let 5, then again suppose NQ 7. Okay, now suppose again NQ 8, then DQ, then display. Okay, in any sequence you can call all these functions. We consider this is a queue. Now how these operations will be done? The display function is remaining. I am just going to again explain the display function also, how to write it, but first before that we will try to understand how these operations will work on this queue. Okay, now currently front and rear -1 we have set, and here this array is having index from 0 to 9. Now what will happen, NQ5 means here initially front and rear both are -1, that means q is empty. In that case what we have done, we have just incremented the front as well as rear. Now both are pointing to 0, and at that place we are just inserting the element, that is fine. Now in this case front and rear both will be 0. Now NQ7 again we have called, in that case we have just incremented rear only, not front. Front will be constant or fixed in NQ operation. Now rear will become 1 and there the 7 element will get inserted. Again NQ8, rear will become 2 and at that place element will get inserted. Now in DQ means what will happen, see here, front equal to -1, no it is false, front and rear both are same, no it is again false, and here see, that's why this else part will be executed like deleted %, means deleted q of front means q of 0. This is the q array, and from that 0th index element we are just displaying as a deleted element like deleted :5, this type of message will get displayed. Okay, now see, deleted 5 and front plus means front will become 1 now, means this will be the front and this will be the rear, means inside that queue only these two elements are present now, and this element is now considered as a garbage value. Now the index of front is 1 and rear is 2. This is the only queue now, and deleted element is nothing but a 5. See here we are just removing the element which is inserted first, means here we are just following the first in first out approach, means this implementation is correct. Now we have to just write display function. In display we have to just display the elements from front to rear, that's it. But before that we have to check whether q is empty or not. How we can conclude that whether q is empty? Simple, if front is -1, in that case we can say that q is empty. Now see, we will write here display function. How to write that? Simple, void display, and here first we will check if rear, you can also check here front. Okay, rear equal to -1, then just printf empty q or q is empty. Otherwise we have to just display the elements sequentially from front to rear. Here we can write like this, printf the q elements are, the q is like this, and from front to rear means here we will just place a loop. Here we have to declare one integer I variable in display function like int I, that we can use here. I is equal to front, we have to start from front up to less than equal to rear and I plus plus. Just display all the elements one by one like printf, and we are just displaying all the elements like a q. That's why just give one space here and comma q of I. Getting? This is just a display function, means here from that q array all the elements whatever present from that front index to rear index sequentially we are displaying. Getting? This is just a display function. Now here what will happen, from front to rear means this 7 and 8 element will get displayed. Okay, and before that we have to check whether q is empty or not. See, here we have just called that enqueue, dequeue, display functions directly inside main, but here also you can write a menu driven program just like we have written inside a static implementation of stack data structure. You can just go through that video, and inside that whatever menu driven approach we have used, that also you can write here inside main. Okay, this is just a static implementation of queue data structure. In the next session we will see dynamic implementation. Till that, take care. Bye bye. Thank you.